Welcome to episode 2 of Mastering AI and ML. Today, we're diving into a critical topic, the difference between AI, machine learning, and deep learning. Many people use these terms interchangeably, but they are distinct concepts. Understanding this hierarchy is essential for evaluating tools and having informed conversations about AI. This program is brought to you by the Series of Thoughts team and by Technovative AI. This distinction matters for three main reasons. First, it helps you spot inflated claims in headlines. Second, it leads to better tool choices by enabling you to select the right solution, not just the most hyped one. Finally, it results in sharper conversations, allowing you to ask more critical questions and communicate precisely. In episode 1, we defined AI. Today, we'll draw the complete map, 3 nested layers, each more specific than the last. This map will show how AI, machine learning, and deep learning relate to each other, clarifying where every tool fits into the big picture. The core mental model is represented by 3 nested circles. Artificial intelligence is the largest field, containing machine learning, which in turn contains deep learning. Generative AI sits at the core. Learning to place any AI system within this hierarchy is a crucial practical skill. Here is a reference visual of the complete stack. AI is the outermost boundary, with ML, deep learning, and generative AI nested inward. We will now build this map, layer by layer, seeing where real-world tools like Scikit-learn and ChatGPT fit in. Layer 1 is artificial intelligence, the broadest term. AI is any technique that simulates intelligent behavior, such as decision-making or problem-solving. This field is decades old, encompassing rule-based systems and search algorithms, with machine learning and deep learning as subsets within it. AI is the field, and everything else lives inside it. Stockfish, a world-class chess engine, is a prime example of classical AI. It evaluates millions of moves per second, using handcrafted rules and algorithms. It's highly capable, but it does not learn from data. It relies entirely on programmer-written rules. This illustrates that AI does not automatically mean learning from data. Layer 2 is machine learning, a specific approach within AI. Instead of writing explicit rules, you train a system on data to discover patterns itself. Classical AI is programmer-written rules for bounded problems. ML infers rules from patterns, adapting to complexity that hand coding cannot handle. Remember, all machine learning is AI, but not all AI is machine learning. Spam filters are a textbook ML application. They learn to classify new messages by being trained on millions of labeled emails. The model identifies patterns, adapting to new spam tactics without explicit rules from a developer. This adaptability is the essence of machine learning's power. Layer 3 is deep learning, a subset of machine learning. It uses neural networks with many layers, learning abstract representations of complex, high-dimensional inputs. This makes it powerful for tasks like image recognition, voice assistants that convert audio to meaning, and large language models for generating human language. Face Unlock on your phone is a deep learning example. It uses a deep neural network trained on millions of facial images to recognize your face from any angle or lighting. This high-dimensional pattern recognition is where deep learning surpasses earlier ML techniques. No handcrafted rule set could achieve this level of capability. Layer 4 is generative AI, the newest layer, sitting inside deep learning. It uses large neural networks trained on massive datasets to generate new content rather than just classify or predict. This includes text generation with tools like ChatGPT, image generation with DALL-E, and code and audio synthesis with systems like GitHub Copilot. This chart summarizes the complete stack of 4 layers. Each layer is more specific than the one that contains it. AI, followed by ML, then deep learning, and finally generative AI. Every tool you encounter fits somewhere in this hierarchy. If deep learning is so powerful, why not use it for everything? Power comes with a cost.
but we
Deep
shall
learning
always
requires
hope to find
enormous
them
amounts of data,
strongly
significant
supporting
compute
their own
infrastructure,
freedom.
and long training
And
cycles.
to remember
For many
that in the
real-world
past,
problems, a simpler machine learning
those who
model delivers better
foolishly sought
results
power
faster and with less
by
overhead.
riding the back of the
Simpler
tiger
ML is better for
ended up
clean,
inside.
structured data, and when interpretability and speed are key. Deep learning is necessary when inputs are complex,
To
like
those
images
people
or raw text,
in the
when
huts and
patterns are too
villages
intricate for
across
handcrafted
the globe,
features, and when you have
struggling
massive
to
data
break the
sets and a
bonds of
sufficient
mass
compute
misery.
budget. The
We
complexity
pledge
principle
our
states
best
that the
efforts to help
complexity
them
of the
help
input
themselves
justifies the model's
for
complexity.
whatever period is required.
Over-engineering with deep learning when a
because the
simpler
communists may
algorithm
be doing it,
suffices is a common
not
mistake.
because we seek their
Matching
votes,
the model's complexity to the
because
problem
it is
is a
right.
skill we will develop throughout
If
this
a free
course.
society
Now, let's place some
cannot
real
help the
tools
many who
onto
are
this map,
poor,
layer by layer,
it cannot
starting
save
with
the
generative
few who are
AI.
rich.
This will confirm your understanding of where each tool belongs in the stack. ChatGPT and
To our
Claude are
sister
large
republic,
language models in the generative
south of our
AI
border,
layer. They use
we offer a
transformer-based
special
neural
pledge
networks trained on
to
vast text
convert
data
our
to
good
generate
words
new sequences
into
of
good
text.
deeds.
They do not retrieve
In a new
pre-written
alliance
answers,
for
but
progress,
synthesize novel,
to
contextually
assist
appropriate
free
output.
men and free
Midjourney and
government
DALL-E are image
in
generation
casting off the
models,
chains
also
of
in the
poverty.
generative AI layer.
But
They
this
synthesize new
peaceful
images from
revolution
text
of
prompts
hope
by generating pixel
cannot
patterns
become
from
the
learned
prey of
associations.
hostile
They
powers.
operate like LLMs,
Let
but with a
all
different
our
output
neighbors
modality.
know that
Scikit-learn
we
is a
shall
Python
join with
library for
them
classical machine
to
learning,
oppose
entirely
aggression or
outside the deep
subversion
learning circle.
anywhere
It's
in the
crucial for
Americas.
tabular data,
And
business
let every other
analytics, and
power
structured
know
problems
that
because
this
its algorithms
hemisphere
are
intends to
fast,
remain
interpretable,
the
and
master of
highly
its own
effective.
house.
TensorFlow and PyTorch are the foundational deep learning frameworks. When building complex systems like image
To that
classifiers or
world
custom
assembly
language
of
models,
sovereign
the
states,
work
the
happens
United
here.
Nations,
TensorFlow is
our
strong in
last
production
best
deployment,
hope
while PyTorch is
in an
dominant in
age where the
research for its
instruments of
flexible
war
design.
have
Zapier
far
and
outpaced
Make are
the
workflow
instruments of
automation
peace.
platforms in the application
We
layer.
renew
They
our
are not
pledge of
ML
support
tools themselves, but
to prevent
consume
it from
AI
becoming
outputs through
merely
APIs.
a forum
This
for
distinction
invective,
is vital for
to
understanding that an
strengthen its shield
AI-enabled
of
application
the new and the
is not
weak,
necessarily an
and
AI
to
system.
enlarge the
This
area
visual
in which
summarizes
its
the
grit
full
may
tool
run.
map, showing every tool
Finally,
in its respective
to
layer.
those nations
Understanding where a tool
who would
sits
make
tells you
themselves our
immediately what it
adversaries,
can and can't do,
we
and
offer
what's
not a
actually
pledge,
happening under the hood.
but a request
The application layer is a
that both
separate
sides
category. Many
begin
daily
anew the quest for
AI-powered
peace.
tools are applications, calling
Before the
AI
dark
systems via
powers of
API.
destruction
AI systems do the
unleashed by
actual learning,
science
while AI-enabled
engulf all
applications use
humanity
AI outputs as a
in
feature.
planned or accidental
Knowing this sets
self-destruction.
accurate expectations about the
We
tool's
dare not
flexibility
tempt
and
them with weakness,
limitations. With this
for
map,
only
you
when
have
our
a filter
arms
for every
are
AI
sufficient
headline.
beyond
You can
doubt,
now ask critical
can we
questions,
be
such as,
certain beyond
which
doubt
layer is this?
that
Is
they
it
will never
classical
be
ML
employed.
or deep learning? What
But
modality,
neither can
training
two
data,
great
and
and
architecture are
powerful
involved?
groups of
This
nations
separates informed
take comfort
practitioners
from our
from
present
passive
course.
consumers of AI hype.
Both sides
Avoid
overburdened
common
by
conflations.
the cost
It
of modern
uses
weapons,
AI often means
both
ML
rightly
or deep
allowed
learning. It's
by the
powered by
steady
machine
spread
learning
of the
might
deadly
mean
atom,
deep learning. It's
yet
AI
both racing
powered
to
might
alter
just mean it calls an
that
API.
uncertain balance
Probe
of
deeper
terror
to understand the
that
true
stays the
underlying
hand of
technology.
mankind's
Here are
final war.
real-world examples across
So
all
let us
four
begin
tiers.
anew,
Stockfish is
remembering
classical
on both
AI.
sides
A spam filter
that
is machine
civility
learning.
is not a sign of
Face
weakness,
unlock is deep learning.
and sincerity is
ChatGPT
always
is
subject to
generative
proof.
AI. Each
Let us
uses a
never
distinct set of
negotiate
techniques
out of
from its
fear,
respective layer.
but let
The
us never
ultimate
fear to
skill is
negotiate.
picking the right tool. Start by identifying the input, structured or unstructured data. Then match the
Let
model.
both sides
Classical
explore
ML
what
for
problems
tabular
unite
data
us,
and DL for
instead of
high-dimensional data.
belaboring those problems
Finally,
which divide us.
validate the trade-off,
Let
weighing
both
accuracy,
sides for the first
speed, and
time
cost. The
formulate
gradient-boosted
serious
tree
and
lesson
precise
illustrates this
proposals
principle. For
for the
predicting customer
inspection and
churn from
control of
structured
arms,
CRM data,
and
a
bring the
classical ML
absolute
algorithm
power
like a
to
gradient-boosted
destroy
tree
other nations
often outperforms a
under
neural
the
network.
absolute
It's
control
faster,
of all
interpretable,
nations.
and doesn't require a GPU. Not every problem needs a sledgehammer. To
Let
summarize,
both sides
artificial
seek to
intelligence
invoke
is the broad
the
field.
wonders of
Machine
science
learning learns patterns from
instead of its
data.
terrors.
Deep learning uses layered
Together,
neural
let us
networks for
explore the
complex
stars,
data. Generative
conquer the
AI
desert,
creates new content.
eradicate
This
disease,
knowledge is your foundation
cap
for
the ocean
building and
depths,
navigating the
and
world of AI.
encourage the arts
Let's
and
review
commerce.
the learning outcomes.
Let both
You should now
sides
be able to
unite
draw
to
the
heed
hierarchy from memory,
in all
give
corners
a
of the
real-world
earth
example for
the
each
command
tier,
of Isaiah
explain when
to
not to use
undo
deep
the heavy
learning,
burdens
and place tools like
and let the
PyTorch and
oppressed go
scikit-learn
free.
in the correct layer. This
And
knowledge gives you a
if a
distinct
beachhead
advantage.
of
You can
cooperation
evaluate claims more
may
critically,
push back
read
the jungle of
documentation with better
suspicion,
context, and
let
make
both
faster,
sides
smarter
join
decisions
in
about which
creating
technology to
a
use.
new endeavor,
You now have the
not a
map
new
that
balance
most
of
people
power,
using AI tools
but a
daily
new
don't.
world of law,
We're curious,
where the
which tier
strong
do
are
you
just
spend the most time in right
and the
now?
weak
Are you
secure
using applications,
and the peace
working with ML
preserved.
tools, or building models from
All
scratch?
this will not be
Knowing where
finished
you are starting from
in the
helps us
first
tailor the
100
depth
days,
of future episodes.
nor will
Coming
it
up
be
next
finished
in
in the
episode
first
3, we
1,000
dive
days,
into how machines
nor in the
actually
life
learn.
of this
We'll cover the
administration,
3 fundamental training
nor even
approaches:
perhaps in our
supervised,
lifetime
unsupervised,
on
and
this
reinforcement learning,
but
with a
let
clear
us
framework
begin.
for when to use each one. Thank you for completing episode 2 on the hierarchy of AI, machine learning, deep learning,
In
and
your
generative
hands,
AI.
my fellow
We
citizens,
covered the 3-circle model,
more than
examples for
mine,
each tier, and the
will rest
complexity
the
principle.
final
Head
success
to
or
episode
failure
3 to learn
of
how
our course.
machines navigate this map.